Okay, now we are going to see how to find the equation of plane. So as you can see from here, there is only Cartesian equation and also the vector equation. So let's recap. Our equation of line is r equals to a plus tv. So that is for vector equation. And for plane, we have r dot n is equals to a dot n. So there is a dot product involved in finding the equation of plane. So here, as you can see, we have three cases normally in the question. So the first one is a plane in space has normal vector, and so it is very important to find the normal. So normal here, you have to know that normal is just the same thing as perpendicular. Okay, so normal vector and passes through the fixed point A. So from the diagram here, you can see that, let's say this is your point A. Okay, this is your point A, labeled as x1, y1, z1, which is your point A. Go to R, labeled as x, y, z. Perpendicular to this point here, we have the normal vector, which is, let's label that as AI plus BJ plus CK. Okay, so now we know that AR here, the direction vector of AR, is perpendicular to the normal. Okay, perpendicular to the normal. So we have, since remember the dot product, we know that if A is perpendicular to B, that means your A dot B is equals to 0. So now we know that this vector is perpendicular to this vector, so we have AR dot N is equals to 0. Okay, so your AR is actually OR minus OA dot with the normal is equals to 0. So now let's rearrange this. OR, just label that as R. OA, let's label that as A, which is any point on the plane. Okay, so here we have dot N is equals to 0. And if we rearrange this, you should get R dot N minus A dot N equals to 0. And that's why we have R dot N is equals to A dot N as our equation of plane. Okay, so now how to find the Cartesian equation? Okay, so we have the vector equation here. So to find the Cartesian equation, so R is just same like line, which is R is actually your x, y, z. I'm going to write it in column matrix form. Dot by normal. So normal here we have AI plus BJ plus CK. So let's put it as ABC is equals to A. A is at any point, which is x1, y1, z1. x1, y1, z1 dot n. N is the same as A, B, C. Okay, so from that we have AX, BY, CZ. Okay, your dot product. So we have AX plus BY plus CZ is equals to, you know that when you do dot product from a point to a point, you'll get a constant. So let's equals to P. So okay, so that is how we find the Cartesian equation of a plane. Okay, so this is your Cartesian equation. So two things for equation of plane. We have the vector equation r dot n equals to a dot n, and the other one is the Cartesian equation of plane. Okay, so that is the first case. So these two equation works for all the three cases here. So let's see the case 2 here. A plane passes through three fixed points. So let's say if you have on the plane here, we have point A, and we have point B, and we also have point C. Okay, so on the plane we have three fixed points. So what you have to do is you have to find the direction vector for AB and AC. Okay, it depends, whatever, for from CB to CA also can. So why we have to find this direction vector? Because you know that if you want to find the equation of plane, you need the normal. Okay, so to find the normal for this one here, we just do the cross product, which is we have AB cross AC. Okay, so first thing that you have to do is you have to find the direction vector, and now you have to find the normal. So we just go to the vector equation of a plane. Okay, just substitute So A here can be at any point, okay, any point, either A, B or C. Okay, so now the third case, a plane has two vectors. So let's say on the plane here we have one, let's say vector A, and we have the other one vector B. Okay, so the same thing, actually you have to find the normal. So we have to find the normal which is perpendicular to these two vectors. Okay, normal. So normal is we have to find the cross product between vector A and vector B. But a little bit different here, if we substitute into the vector equation, we have r dot n equals to a dot n. A here is actually a vector. So remember here, a vector that is perpendicular to another vector, the dot product is equals to 0. So here we will have r dot n equals to a dot n, which is will be equals to 0. Okay, so your Cartesian equation will be looking like this: ax plus by plus cz is equals to 0. Okay, so that is the three cases that the question might ask. So let's just go straight to the example. We have example 28. Find the equation of a plane with normal vector I plus 2j plus 3k. So this is your normal vector. Okay, so label that as n is equals to I plus 2j plus 3k, and containing the point negative 1, 2, 4. So that is your A. Okay, negative I plus 2j plus 4k. Okay, so if the question asks to find the equation of plane, the first thing that you have to do is write the formula. R dot n equals to A dot n. Okay, that is the first thing that you have to do. So R, just leave it like it is. N here is I plus 2j plus 3k. I plus 2j plus 3k. A here is the point, negative I plus 2j plus 4k. And the other n is the same n as before, dot with I plus 2j plus 3k. Okay, so what we are going to do is we are going to solve on the right hand side, the dot product on the right hand side here. So as you can see, this is actually your first case. Okay, case 1. So here we have r dot I plus 2j plus 3k. So on the left hand side, just leave it like it is. The dot product here we have to find negative 1 times 1, we have negative 1. 2 times 2, we have plus 4. 4 times 3, we have plus 12. Which is here we'll have 15. Okay, so on this side here, just leave it like it is. So that is your your vector equation of a plane. Okay, so now let's try to find the Cartesian equation of a plane. So what we have to do here is, this is actually your x, y, z. Okay, so if we do the dot product between x, y, z and I 2, 3, I plus 2j plus 3, we should get, okay, let me just write this quickly, xi plus yj plus zk dot with I plus 2j plus 3k is equals to 15, and on the left hand side we should get x plus 2y plus 3z equals to 15. Okay, remember I dot I will equals to 1, so we left with x, y, 2y and 3z. So this is your Cartesian equation of a plane. Okay, so that is how we find the equation of plane. Remember, the first thing that you have to do is write the equation first. R dot n equals to A dot n. That means you need a point and also the normal vector. Okay, so let's say example 29. Find the equation, find the Cartesian equation. So the question specifically asks for Cartesian equation of a plane through A, B and C. So there you have the 3 points. So this is the second case. Okay, so let's just quickly draw the plane here. We have, okay, so we have on the plane, we have A, B and C. Okay, point A, point B and point C. Okay, so what do you need in your equation of plane? We do need r dot n equals to A dot n. Okay, that means we need the normal and the point. So point, you can choose either one of these points here. So we need the normal. So you know that the normal is perpendicular. Okay, perpendicular to the two vectors. So we don't have any vectors here. So what we have to do is we have to find the direction vectors. Okay, so what we have to do here is we have to find the direction vector of AB and AC. Okay, you can also choose BA to BC, and you can also choose CB to CA. It doesn't matter as long as it starts from one same point. So now we have to find direction vector of AB, which is here we have OB minus OA. So here we have B is equals to 311, A is equals to negative 120, which is here we have 4, negative 1, 1. And we also have to find the direction vector of AC, so which is OC minus OA. So C here is 103 minus negative 120. So here we have 2, negative 2, 3. Okay, so we have the direction vector of AB and AC. So what we need to do here is we need to find the normal. Okay, normal to the plane, which is this one here, perpendicular to these two vector. So you know how to find the normal, which is we have to do the cross product between the two vectors that we have. So N is equals to AB cross AC. Okay, very, very important, this part here. Okay, so let's find the normal here, which is AB. If you don't know, if you don't remember how to find the cross product, check out the previous video. So here we have AB is 4, negative 1, 1. AC is 2, negative 2, 3. Okay, so here we have negative 3 plus 2i. Remember, minus plus minus. So here is minus. Tutup yang ini, we have 12 minus 2j. And last one is negative 8 minus minus 2. So we have negative 8 plus 2k. Okay, always remember plus minus plus. So now we have the answer, negative I minus, here we have 12 minus 2 is 10, so negative 10j minus 6k. Okay, so that is your normal. So what is left to do is to find the Cartesian equation, which is we have the vector equation of a plane. Always start with the vector equation. Okay, so r dot n is equals to a dot n. So r dot n here is this one here, negative 1 minus 10, negative 6 minus 10 minus 6 equals to, a can be at any point. You can choose A, B or C, so that it doesn't matter. Okay, you are going to get the same answer, 0, and normal is still negative 1, negative 10, negative 6. Okay, so to find, okay, let's see, this one is any point. Okay, either A, B or C. So the question asks to find the Cartesian equation, so we just write this as negative x minus 10y minus 6z equals to, find the dot product on the right hand side. We should get 1 minus 20 plus 0, which is negative 19. Okay, so this one here, negative x minus 10y minus 6z equals to negative 19. Okay, and you can just divide everything with negative 1. We'll have x plus 10y plus 6z equals to 19. Okay, so this is our Cartesian equation of the plane. Okay, so very easy. It's not that complicated. You just have to find the normal by finding the cross product between two vectors. But now you don't have the vectors, you have to find the direction vectors first. Okay, so let's see. Okay, now I'm going to introduce a little bit more on the plane. Okay, so we have a plane here which is parallel. If the question said that the plane is parallel to xy plane, Okay, if the plane is parallel to xy plane, so let's draw the axis here. We have we have x, z and y. Okay, xy plane means xy plane, so the plane is somewhere here, okay, on this line here. Okay, so your plane is there. So if the question said the plane is parallel to xy plane, so your plane should be on here. Okay, so that means what we know from here is the normal here is equals to, normal to this plane is equals to k only. Okay, because you know that this direction is k, so your normal for x, that for the plane that parallel to xy plane is n is equals to k, or we can write as a vector 0 0 1. Okay, just k. Okay, what about when the plane is parallel to xz plane? Okay, if the plane is parallel to the exact plane, so let's see the axis here. We have x, y, z. Okay, x, z plane. So we have x, z plane. So your plane is somewhere there, somewhere here. So your normal will be parallel to the y-axis here. So that should be, here is your normal, and your normal for this is gonna be equals to, what is your y? J. Okay, only j. So as a vector, we can also represent it as 0 1 0. Okay, only j that we have here. Okay, that is for a plane that is parallel to xz plane. And of course we have another one, which is, let me quickly resize this. Okay, we have another one which is parallel to yz plane. Okay, so if we write the axis here, we have x, z and y. So you have yz plane, this is your y, this is your z, so your plane will be somewhere there. So which is the normal for this plane is going to be like this, okay, perpendicular to the plane. Remember, the normal always perpendicular to the plane, so this one here will be normal equals to I, because it goes in the x direction here. So as vector, we can always also represent this as 1 0 0. Okay, so that is one thing that you have to know about plane. Okay, the plane that is parallel to xy plane or xz plane or yz plane. So let's see example 30. Find the vector equation of the plane that contains 2, -1, 3 and is parallel to the xy plane. So now you know that your xy plane here, xy plane, the normal is equals to k. So you don't have to like complicating to find the normal. So you can just put the normal is equals to k. Okay, so now the vector equation of a plane r dot n equals to a dot n. So r, just leave it like it is. The normal here is k, just k. Okay, just k. 0i plus 0j plus 1k. So we can just write as k there. So a is the point here. This is your a. So we have 2, -1, 3. And the normal is just k here, should be 0 0 1. Okay, so 0 0 1. So the dot product on the right hand side here, we have 0 plus 0 plus 3, we'll get 3 here. So on the left hand side, just r dot k. Okay, that is for vector equation. So let's see if the question asks to find the Cartesian equation. So x, y, z. This one is 0i plus 0j plus 1k. So that means x times 0 0, y times 0 0, z times k is 1. Okay, so here should be zk times k, zk dot by k, you'll get z only equals to 3. Okay, so this is your Cartesian equation. Okay, so let's see question B. Parallel to the plane, find the vector equation of the plane that is parallel to the plane with equation 3x minus y plus z equals to 2. So this is new to us. We have, okay, let's label the plane that we want to find as P1. Okay, and the plane that we have here as P2. Okay, and let's draw that. We have one plane that we want to find, which is this is our plane 1, and we have another plane. Okay, another plane that is parallel to our plane. So this, let's call this as plane 2. Okay, parallel semua orang tahu parallel tu apa. Kita cuba kamu ambil satu kertas A4 and you put another one A4 on that paper. That is what we call as parallel. Okay, so we do know about this plane here, which is what we know from this plane is that the equation for P2 is 3x minus y plus z equals to 2. Okay, from that you know the normal. Okay, so remember the Cartesian equation. Cartesian equation is ax plus by plus cz equals to the dot product. Okay, the value for the dot product. So from here you can see that a, b and c is actually your normal. Okay, your vector, your normal vector. So this is your normal, equals to ai plus bj plus ck. So from this Cartesian equation here, we do know the normal. Okay, so we have the normal, which is 3i minus j plus k. Okay, okay, and we also know that this plane is parallel to this plane here. So we know that plane 1 is parallel to plane 2. So from that, as you can see, the normal for plane 2 is this one here, perpendicular. Okay, perpendicular to the plane, going here. This is the normal one. Okay, and also the plane, sorry, this is plane normal 2. Okay, which we have here, normal 2. And this is what we want to find. Okay, we want to find the normal for this plane here. So as you can see from here, this is the normal for plane 1, and the normal for plane 1 is actually parallel to normal from plane 2. Okay, what we know, P1 is parallel to P2. That means the normal from plane 1 is equals to normal to plane 2. Okay, remember back to equation of line. If you have two lines that is parallel, the vector equation is the same. So the same thing works here. You have two normal that is parallel, so this normal can be equals to this normal here. So the normal for plane 1 we can write as 3i minus j plus k. So now we can find the vector equation, which is we have r dot n equals to a dot n. So we have r dot, the normal is 3 negative 1 1 equals to a is the point that is given in the question here. We have 2 negative 1 3, and the normal here is just the same, which is dot by 3 negative 1 1. Okay, look at this. This one here, I represent our vector as this sharp bracket here. Okay, this one here, I represent the vector as the round bracket or column matrix. Okay, this one here, I represent the vector as I, j, k. So that is the only 3 ways to write your vectors. Okay, there is no more ways to write the vectors. Okay, there is only 3 ways. So please don't write your vector just like this. That is gonna be wrong. Okay, so now let's just put this as the vector equation. So we have r dot 3i minus j plus k, and the dot product on the right hand side will be 6 plus 1 plus 3, and that's gonna be 10. Okay, so we have dot 3i minus j plus k. So that is your vector equation. Okay, and for the last example here, we have two questions. We have to find the Cartesian equation for each of the following planes. So as you can see from the first example, first question here, the plane pi1. Sometimes P1, plane 1 is labeled as pi1. So don't just get confused. Just a label. So we have the plane 1 through A and perpendicular to the line x plus 1 over 2 equals to y over 3 equals to z over negative 1. So let's just draw our plane here. We have plane 1. Okay, label this as plane 1 that we want to find. Okay, this is our plane 1 and this is our line 1. Okay, so we have the plane 1 here, which is the question said that the line is perpendicular to the plane. So we have a line here. Okay, we have line perpendicular to the plane. So line here is x plus 1 over 2, y over 3 equals to z over negative 1, which we have the vectors. Okay, remember for the parametric equation here, this is the vector. Okay, the denominator is the vector. So we have v for the line as 2i plus 3j minus k. Okay, so from that we know that to find the equation of plane 1 we need the normal. So as you can see, the normal is perpendicular to the plane. Okay, and from that you can see that your normal is parallel to the line. Okay, your normal is parallel to that line, so you can use the vector from the line as the normal for the plane. Okay, since let's just ulang balik, the plane 1 is perpendicular to plane 1 is perpendicular to the line 1. Okay, so that means the normal for plane 1 is equals to 2i plus 3j minus k. Okay, normal for plane 1, normal for plane is equals to vector line. Okay, so now we just substitute into our vector equation. So we have r dot n equals to a dot n. So r dot n, and here is 2i plus 3j minus k, and a is at any point, which is as from here the plane through a1 to 3. So that is your a. So we have I plus 2j plus 3k dot by the normal 2i plus 3j minus k. So let's just find the answer. We have the question asked to find the Cartesian equation. Okay, so that should be 2x plus 3y minus z equals to the dot product on the right hand side should be 2 plus 6 minus 3. Okay, which is we have 5. Here we have 2x plus 3y minus z, and that is your Cartesian equation of plane 1. Okay, so for question B, so here we have the plane 2, here pi 2, sometimes labeled as pi, it's just p2, plane 2 through B, point B, and perpendicular to both plane here and plane here. Okay, so let's label this as plane that we want to find is P2, we have P3, and we have P4. Okay, so let's write that down first. We have P3 is equals to x minus y plus 2z equals to 3, and we have P4 is 2x plus y minus z equals to 3. Okay, so what is the situation here? We know that these two planes is perpendicular to this plane. Okay, or this plane is perpendicular to this two plane here. So let's just draw the situation that we have here. Okay, we have a plane. Okay, let's label that as P3, and we have another plane, and let's label that as P4. Okay, so this is your P4. So the plane that we want to find, which is P2, is perpendicular to this both plane. So what we can do here is we have another plane that is perpendicular to this two plane here. So it's gonna be looking something like this. So this is P2 that we want to find. Okay, that is P2. So how to find P2? So from there you can see that your P3, the normal for P3 and P4 is actually, we have the normal for P3 and P4. So P3 has a normal. Remember, the normal is always perpendicular to the plane. So here is your plane. Perpendicular to the plane is just going to here. Okay, so this is the normal 3, which is the normal 3 here. We have 1, -1, 2. Okay, we have 1, -1, 2. Okay, so that is your normal for 3. Okay, how about the normal for 4? Which is also perpendicular to the plane, okay, which is 90 degree to the plane. So the plane is like this, so the normal is somewhere here. Or let's go on this direction. Okay, so that is gonna be your normal 2, which is equals to, sorry, normal 4, which is equals to 2, 1, -1. Okay, 2, 1, -1. Okay, so let's write that down. We have normal 3 equals to I minus j plus 2k, and we have normal 4 equals to 2i plus j minus k. So now the question is, we want to find the equation of plane 2. So to find the equation of plane 2, we need r dot n equals to a dot n, which we already have a, which is this point B here. So what we need is the normal, okay, for plane 2. The question now is, we only have the normal for plane 3 and plane 4. Okay, the normal for plane 2 is like this here, perpendicular to the plane. Okay, this is normal plane 2. So how are we going to find this normal here? Okay, if I draw one more time, this is normal 3, one vector. This is normal 4. How are we going to find the vector that is perpendicular to these two vectors? Okay, what we have to do is just basically find the dot product between this, sorry, the cross product between these two vectors. Okay, so one more time, we have the normal 3 here, and we also have the norm. You can just go in the same direction. Okay, this is normal 3, this is normal 4. Okay, you can go on the same direction, normal 3, and we can go normal 4. The question is, we want to find the normal 2, which is perpendicular to these two vectors. So just apply your cross product here. So we have ijk. Normal 3 is 1, -1, 2. Normal 4 is 2, 1, -1. So here you should get the answer, -i plus 5j plus 3k. Okay, so now we have the normal for plane 2. So we just substitute into the equation of line, r dot n equals to, sorry, equation of plane, a dot n. So we have r here, the normal is -1, 5, 3. The point is 1, -1, 3 given in the question. Here we have -1, 5, 3. And remember, the question asked to find the Cartesian equation. So here we should have -x plus 5y plus 3z, and here we have -1 minus 5 plus 9, and that should be equals to 3. Here we have -x plus 5y plus 3z. Okay, and you can also divide everything with negative, and you have x minus 5y minus 3z equals to -3, or just leave it like it is. Okay, so this is the Cartesian equation of a plane. And here is your exit ticket 14, which is, we have 2 questions here. So make sure you read it carefully and find the equation of line and also the equation of plane here. Okay, don't forget to submit this on GC. I'll see you guys in the next video.